Is Physics and Art, Lecture 1, and I'd like to begin today's lecture with a quick demonstration. I have here an Arduino board with a photo light sensor hooked up to just a laptop and connected through a serial port to Flash program. And what I have done is created a movie of an airplane flying, and the plane kind of moves around, and as you put your hand over the light sensor for the Arduino, the plane disappears and music comes on. And the effect in this case is the absence of this plane and the introduction of music. So kind of want to look at this as just an experiment. Now, I'll go ahead and close this. This brings up an interesting concept, and the concept that I want to introduce today is called quantum entanglement. And quantum entanglement has a lot to do with the difference between the classical physics measurements that we can make and the quantum physics measurements we can take. In other words, at what point are these objects entangled where classical theory breaks down into quantum theory and vice versa. So it's also important to note that during this phase, if you measure something in the quantum mechanical sense, the wave function of it collapses to a singular result. So we go from a range of probabilities and possibilities to a singular measurement. So I want to question, at what point does the classical limit go into quantum mechanics, and vice versa. I want to also know, is there some sort of continuous spectrum between the classical and quantum mechanical modes of thinking? And what does that mean in terms of how we produce art, and how can we represent the world, if that's our job as artists, to see things both in the classical and quantum mechanical sense? So as an exercise for the student to look up Schrodinger's cat, which is just a thought experiment having to do somewhat with this. So let's set up our driving motivation. I think it's always good to have a strong drive if you're going to push forward with anything. We want to know, one, let's look at an acceptable model for our universe. In other words, is it one or the other, a combination, going back to this spectrum? What does it look like? As artists, again, I think it's our responsibility to show the world in the sense that no one else who is not an artist can represent it. And can we represent it visually? So let me just make some space here. I want to go back to the demo example, and in the demo example, I'll go ahead and describe this in a quantum mechanics kind of sense, we have a state P. Let's write it like this so we don't confuse it with the momentum vector. And this is a state function, the wave function of the airplane. And the state is broken down, or could be broken down further into a series of probabilistic states. Let's say P1, P2. And I would say that this wave function has momentum, and it also has a spatial component. I would like to say that when we performed the experiment, the measurement, and the plane disappeared, that we have some sort of anti-state for the plane function, which I will call P dagger. And this is just following a trend of linear algebra and the Brockett notation. So we call this the anti-state. And it's some altered or alternate state of our original plane wave function, but it has been collapsed. In other words, we went from a range of possibilities of the plane and how it flies and where it's located and its momentum to a singular state where we can precisely measure the position and momentum of the object. In this case, the result of the experiment again was that the plane actually disappeared and that we have this introduction of a new sound. But I'm wondering, with this collapsed function, is it re-expandable? And I think that is a benefit of being an artist and looking at this type of problem, that we can imagine things that may not make sense in the physical world, and they don't have to be applied to laws. But we can take the laws that do apply to our physical world and universe and kind of map them onto our artistic works, and from there generate new ideas and new things. So with all this, I'm going to write something like this, where I have the anti-wave function, this P dagger, with our original P wave function. And I'm going to say that from this we get some new value, SMB, and our old wave function back. We can represent that in terms of eigenvalue, eigenvector with omega and some new wave function P. Alright, so the kind of old concept that we've been discussing so far is about indeterminacy and probability being funneled down to an exact state. Again, in this case, the absence of a plane, introduction of sound. Well, what about this new concept where maybe there is something that is controlling the experiment? In this case, it was me putting my hand over the photosensor, but what if there is some sort of unknown controller, an unknown driving impulse? And I think we can go back to Einstein had a quote for how the spin states of electrons can change at a distance, and he called it a spooky action at a distance. It's kind of interesting, the things that control us that we are not aware of or that we cannot describe fully. So if you are following the lecture notes now, I'm headed to page 3. And this is kind of a third state in our drive, and that state is questioning, always question. So apparently there was some action in this demo of one thing on another that alters that thing. So my hand altered the state plane and introduced something new. So let me write this out, that there is something, and we'll call it thing 1, that takes action, another thing, thing 2, and thing 2 becomes altered through this action, this impulse. I want to know, is thing 1 affected? Question mark. And is thing 1 the impulse this guiding unknown something, is this impulse guided by some third thing, thing 3? Question mark. I mean, it's an interesting question when we talk about what exists and what interacts with something else, and it seems that we can always step one level back. We can always integrate backwards over what has happened to come up with something new. We know that an integral over a function can lead to a line, it can lead to a surface area, it can lead to a volume. So let's make a quick diagram where we have a thing 3, a thing 1 is here, and a thing 2 let's call them physical objects. We want to know, is there some impulse that acts between thing 3, 1, and 2, and is there some sort of feedback for this system? Typically in nature there is some sort of reactionary response, or biologically when chemical levels are increased, they are then scaled back by a feedback loop. So that's an interesting question. Am I changed by changing the plane experiment, or by creating it? A second diagram I want to show would look something like this. We have a thing. In this case, I'm putting in a bracket notation. And it might have some mass and velocity, and that would lead us to a momentum vector. It has a position. That would lead to a position vector. And we have some impulse. I'm wondering if we can write the impulse acting on a thing leads us to some new value, like we have here, to a new thing. I'll leave this n superscript to imagine a world of multiple things or infinite things. And I'm wondering if we can write some sort of